Interfaces in C#. So interfaces are another way to achieve abstraction in C#, and we talked a little about abstract classes before, and abstraction is a key object-orientated principle, which is just the process of hiding the internal details and showing only the functionality. So let's take a look at interfaces in C#. So as a mini refresher, I'll just refer to this project where we made an abstract animal class here. So here's our abstract animal class. We have some private fields and some kind of public methods here, and also some public properties. I have one abstract method here, and because the dog class here is inheriting from the abstract class animal, it has to override this abstract method. It's kind of forced to do that, and that's kind of the point of abstract classes. So through polymorphism, we're kind of overriding this method make noise, and we're just outputting woof woof for our dog class. So when we create a new dog object and run the method make noise, we just get woof woof. So in principle, that's the abstract class there. We're sort of forced to override these abstract methods here. Let's take a look how we can create an animal interface and also see how, interfaces differ from abstract classes as well. So interfaces in C#, quite similar to abstract classes. What I'm going to do is create a brand new interface in C#, and then I'm going to show you a few differences between abstract classes and interfaces, and then our dog class here is going to use our brand new interface. It'll all become clear momentarily. So if we go over to the right hand side here to our project, right click, go to add, and then go to class. From the menu here, we just choose interface. Now we can give the interface whatever name we would like, but I want to create an animal interface. When creating interfaces, it's always good practice to use a capital I beforehand. And that's because when you add interfaces, or at least you have a really large project with maybe tens or hundreds of interfaces, you can distinguish them from normal classes. So here we have animal.cs, and you can see iAnimal.cs. So this one's clearly an interface just because we've named it that way. So it's just good practice. And the difference between an interface like this one here and a class like this one here is just the difference in the keyword, which is we have a class keyword for a class and the interface keyword for an interface. Pretty much anything else right here is the same. So that's the only subtle difference here. Now interfaces in C#, you can consider them as pretty much 100% totally abstract. What does that mean? Well, if you've watched the abstract class tutorial, like this one here, we have some abstract methods here. And when we have an abstract method, we don't define a body for it because our classes that inherit this abstract class, they define their own methods for them, like the dog class and the cat class, for example. They provide their own code. So when we go to our abstract class, it has no body, for example. However, an abstract class can define its own methods like say name, say age, and they can do kind of various other things as well. This is not true with interfaces. So consider an interface as a purely kind of abstract class where you don't define bodies. There is a little exception for that rule to do with private members, but I'm going to discuss that perhaps later or at another time. So consider interfaces as like a purely abstract class. So we're not defining bodies in interfaces for our methods. So if I come over to my dog class right here, which is inheriting from this abstract animal class, you can see I'm overriding a make noise method and then giving it my own functionality. I want to do the same kind of thing in my interface. So in my interface, I want to define a method called make noise, which is going to be abstract because that's the purpose of the interface. So if I define a new method called make noise, like I say, because it's abstract, I don't have a body here. And by default, this is public. The access modifier is public by default. And this is just by design of interfaces, because we want everyone to use these interfaces. So just like that, we've defined our very first method in our interface. Very simple, isn't it? And because it's public and abstract by default, We don't need any access modifiers like public, it's optional, and we don't need the abstract keyword, for example. So this is how to define a public abstract method in C# for an interface. So now I go over to my dog class. Right now it's inheriting from this abstract class animal right here. I want to implement the interface. So I'm just going to put an I in front so it now uses our interface instead of our abstract class. So now how do we kind of rewrite this to make it work with our interface here? Well, when we inherit from an abstract class and we have an abstract method, just like we talked about before, we use the override keyword here. But with interfaces, we don't use the override keyword. It's not needed at all. So this is perfectly sufficient, for example. One other thing, if we choose not to define a method for our interface and just leave it like that, if we hover over this here, it's saying dog does not implement interface member make noise. So just like abstract classes, it's kind of forcing us to provide an implementation for that method. So it can kind of force us to do that. And when you have large teams of people, for example, it's quite handy because then all your classes are somewhat standardized and they all will kind of override this make noise method here, just like we talked about before in abstract classes. So now I have this dog class here. It's implementing the make noise method, which we defined in our interface, and through polymorphism, it's defining its own functionality. So if I go over to the program here, where we create a brand new dog object, and we're calling the make noise method, which is available through the interface, we're going to get exactly the same result. So let me just go over some similarities and also some differences between abstract classes in C# and also interfaces as well, because perhaps on the surface they achieve a very similar thing. So before, when we tried to create an instance of an abstract class, it wouldn't let us. It's not possible. And this is through design. So even if I try and do the same thing with an interface, for example, it's not going to let me. Even Visual Studio isn't offering an autocomplete feature for this. And when I hover over this new instance attempt here, it's saying it can't create an instance of the abstract type or interface iAnimal, so it's not possible. So in an abstract class, we can have a constructor, but it's only called by the child classes, not anywhere outside of that kind of inheritance chain. With interfaces, you cannot have a constructor because you would never, under any circumstances, construct an interface. The interface just acts like a contract, so anything implementing the interface can kind of override those methods that are available. So no constructors in interfaces. If we want to do that, then the purpose is we have a class and then we implement an interface, or we inherit from an abstract class and then define our own overrides for these abstract methods, for example. So this is why we don't create new instances of abstract classes and interfaces, and therefore we don't need a constructor. Something else we also touched on was the fact that abstract classes can have fields right here, which you cannot have in an interface. And again, in methods here, we can define bodies in abstract classes. However, in interfaces, we can't because it's purely abstract. So these are some differences here. So you may be asking yourself the following question. Why should I even use an interface when in an abstract class, for example, I can use fields, I can define method bodies if I want to? Why should I use an interface? What's the point? It seems more limited. Yes, maybe it's 100% abstract, for example, but why should I use one? Well, interfaces support the idea of multiple inheritance in C#. So for example, if I have an animal interface like iAnimal, I can create an interface called maybe iCarnivore, for example. And then our dog class can actually implement from iAnimal and iCarnivore, or maybe something else like iHerbivore, so it can implement from multiple classes up here, multiple interfaces, and you cannot do that with abstract classes. So this is one of the main strengths of interfaces in C#. So let's take a look at an example right now. So if I come over here, I right click the project, go to add, class, interface. I'm just going to create iCarnivore. because a dog's a carnivore, it's also an animal. Maybe there's a better way of representing this, but let's just go through this example so you can see the point of this. So in iCarnivore, I'm just going to define a method called maybe eat meat, because all carnivores eat meat. So just like that, again, it's abstract and public by default, so that's all we need in this case. And now, if I want to inherit or implement from multiple interfaces, I separate the class from the colon, just like before, and then put in the class or interface I want to implement or inherit from. But if I want to inherit from multiple interfaces, I just put a comma here. And then I can put the next interface. So iCarnivore, for example. And now you can see there's a red line because it does not implement our new member, eat meat, which is true. We haven't defined a method to do that. So if I go to here and type in eat meat, so now I'm implementing that method here from iCarnivore, and I'm implementing this method from iAnimal. So now everyone's happy, there's no red lines, everything's satisfied. I can then put my own definition. Something like eats meat. So then if I come over to my application here, and I just type eat meat, for example. Now this is the method that we're kind of implementing from our brand new interface, iCarnivore eat meat. So now, let's get rid of that because we can't create a new instance of an interface. So now I'm creating a new dog object and I'm now eating some meat. And that's a member of our new interface. So you can see here, this is a very quick example of multiple inheritance in C#, and it's achieved through using interfaces, which is something you cannot do with abstract classes. So these are the benefits of both. So you can see that through using interfaces in C# and also abstract classes, we can achieve abstraction, which is a key object-oriented programming principle. Now, testing your knowledge of inheritance, or maybe just querying that you fully understand this subject. For example, if I go over to my main application here, I can create a new method here, and for example, I'm going to call it make noise. It's not going to return a value, it's just going to make some noise about our animals to the console window. And it's going to take one parameter here. So, because dog implements our interface iAnimal, and because we know through talking about inheritance before, a dog satisfies the is a relationship, a dog is an animal. Similarly, our cat class, a cat is an animal, a hamster is an animal. Then we can just go over to here and take in animal as a parameter. And because our dog implements this interface here, then we can do things from here. We can say make noise. So what we can do here, we can create a dog object, and then we can pass our dog to this method right here called make noise. Then because the dog is an animal, then this is going to work no problem. It's going to call the make noise method on the object here dog, which is an animal. It is an animal. So if I create a cat object, I can use this same method because cat would implement iAnimal in this case. I could create a dolphin class. As long as it implements iAnimal, again, I can call this method no problem. So you can see this is the power of inheritance, but also using things like interfaces. And this also works with abstract classes too, just like before, no problem, as long as my dog class inherits from the abstract class animal. So you can see now if I run this program, you can see it's now saying woof woof. And similarly, if I have a cat class, like this one here, it implements from iAnimal, the make noise method, and overrides its own kind of logic here, which is meow. So then I go to the program, I create a new cat object, and then I want to make noise with the cat. And as long as it's implementing our interface, then it's going to work no problem. So you can see the power of inheritance and why we use interfaces. We just have to pass the interface around the software, for example, as a method parameter, or even a return from a method, or pretty much anything. So again, if I run the program, you can see through polymorphism, we're overriding the make noise method for dog and cat, but also using interfaces to kind of pass that object around the program. So you can see it's quite powerful, and the possibilities are also endless. So you can see here, if I change this interface to our abstract class here, go to the cat class and make sure it implements the abstract class. With abstract classes, we use the override keyword because that's the difference between those and interfaces. We reflect that also in the dog class, and then go back to our main program here and then run the program. You can see we've passed around an abstract class and it works exactly the same as an interface. But there are subtle differences, like we've discussed previously, between interfaces and abstract classes. But this is an example of both, how they compare, and also the advantages of using interfaces to satisfy multiple inheritance in C#. So I hope this tutorial helped you, and thank you for watching.